All right, guys. Moving on to section 2.7. We're going to talk about combining functions today. Okay, so today is going to be combining functions. Tomorrow is going to be the composition of functions. Or I guess maybe that'll be Monday. Tuesday, we will talk about like inverse functions. Wednesday, wrap everything up. Thursday will be our test. Okay, so if we are going to combine functions, the way we combine functions is through our operations: adding, subtracting, multiplying, dividing. Okay, and to be honest with you, you've already done this. You've done a lot of this actually. Okay, because if I give you a function that is like x squared plus 3x, okay, and I ask you to evaluate that at, let's say, 3, okay, you would plug it into x. You would plug 3 into x squared, right? Get a result. And then plug 3 into 3x, get a result. And then you would add those results together, correct? Okay. So basically what we're saying here is that x squared is actually a function all by itself. We can call x squared f of x. We can just call 3x g of x. Okay. And if I add those functions together, we get a function that we call f plus g of x. Okay? So our functions that we've dealt with are already functions that have individual functions or smaller functions that have already been combined to generate the current one. Does that make sense? Okay? We can do the same thing with subtraction, do the same thing with multiplication, okay, and do the same thing with division. All right? Remember what we're doing here. When I say f of x plus g of x, that ultimately means I'm adding y values, because f of x is by definition a y value for some particular x value, right? Okay. G of x is a particular y value for some x value. Okay. So when I say that I'm trying to take f of x plus g of x, and it's this function here, that is a rule to generate the sum of the y values from f and the y values from g at certain x values. Okay. So this is the notation that we use when we're talking about like summing two functions. Okay. A lot of times I like to write that one first, like f of x plus g of x, the same thing as f plus g of x. If I want to go f minus g of x, well, all that means is f of x minus g of x. If I want to do f times g of x, all that means is f of x. So the y value at f of x, or that is defined by f of x, times the y value defined at g of x. And we do the same thing with division. Is that okay? All right, so if I'm adding, so basically what we're doing here is we're adding y values or subtracting y values. So we're doing our operations with y values. So let's say I have a y value that is 3, and I add to it a y value that is 5. Is that equivalent to taking a y value of 5 and adding to it a y value of 3? Are those two things the same? Yes, okay? So when I take a function like this, like f of x is x squared and g of x is 3x, is that the same thing as saying 3x plus x squared? Does that make sense? Okay. So what we find out is that the commutative property, because of the way it exists with real numbers, exists with functions. Okay, and function addition is commutative. Okay. Now if I were to say, is 3 minus 5 the same thing as 5 minus 3? That is not true, right? Okay, so commutative property does not exist for subtraction. So x squared minus 3x would be different than 3x minus x squared. Same properties, because multiplication is the same thing as addition, right? Okay, multiplication is repetitive addition. So the multiplication property is commutative. And division is just repetitive subtraction. So because subtraction was not commutative, division is not commutative. Okay? So we'll ask you little questions like that throughout homework. A lot of times on a test or a quiz, an author will say find f of g of x, so that is f of x, whatever that function is, divided by g of x, whatever that function is. And then they'll say, okay, now find g of f of x, which would be g divided by x divided by f of x. And then they'll ask you to make a conclusion about your results. Now, they're probably going to be different, okay? Because the commutative property doesn't hold for division. Okay. Okay, so it says of course, the sum on the right-hand side makes sense only if both f of x and g of x are defined. Okay, so this right here only makes sense if f and g themselves are defined for the x value. So, what do I mean by that? Let's take let's say f of x is equal to 1 over x minus 3, and let's say g of x is equal to just say x squared. And I don't care what operation I'm going to do. We can do subtraction, multiplication, division, addition. Doesn't matter to prove this point. But if I want to find what f plus g is for x, that means I have to have understanding that f of x is going to give me a y value. That's going to give me a legitimate real number output. And g of x is going to give me a legitimate real number output. Okay? So here's my question. If I plug in, let's say, 0. Okay? If I plug in 0. So if I ask you, what is f plus g of 0? Can you do that? If I plug 0 in right here, I get 1 over 3, right? Negative 3, so I'll change that to negative 1/3. And then if I plug in 0 to this function, I get 0 back, right? Can I take negative 1/3 plus 0? Is that legitimate? You get an output there, right? Negative 1/3 plus 0 gives me an output of negative 1/3. What if I did this, though? What if I asked you to find f plus g of negative 3? Not negative 3, positive 3. If I plug positive 3 in right here for x squared, do I get something back? Get 9 back, right? So I get an output there. What happens here? 1 divided by 0. So essentially what I have is undefined, a number that you do not have, a number that does not exist, and you add 9 to it. What does that give me? Something that does not exist, essentially, right? Does that make sense? Okay. So you cannot evaluate f of x plus g of x here at 3 because 3 does not belong to one of the domains of those functions. Okay. Now, we always want to be able to understand what our domain of our functions are. Okay, and that's kind of a trial and error type thing. There's actually a technique that's going to generate these domains for us pretty easily. But what I want you guys to see on the graphical side of things real quick is what we just did and what logic there is behind why we can't add those things together. So let's see if I want to change my settings here real quick. It's kind of ridiculous, but all right, so I'm going to take a function like let's go square root of x and subtract 3 from that. And then I'll have just the line y equals x. So I have those two things. Okay. If I'm looking at those two functions, and I want to figure out what f plus g of, let's say, 1 would look like. Okay, now don't worry about what it's graphing there. That's messed up. If I wanted to see what that looked like, okay, what that really means to me is that if we go to f of x, which is x minus this curve right here, and I go to an x value of 1, it's taking that y value of -2. Does that make sense? And if I look at the same thing on y equals x, so go to 1, it gives me a y value of 1. Okay? Well, if I go f plus g of 1, then it's essentially adding those two things together. Does that make sense? So it should put a point. If I add those two together, what does it give me? -1, right? So when I evaluate this, f plus g at -1, or sorry, +1, I should get a y value back. It doesn't know. Oh, that's why. So g of x equals x. It didn't know what the way I had g defined. If I do that, do you see then it obviously gives me the curve. It summed those two things together, but did it put a point right there at the sum of the red and green functions? Okay, and if I went to 2 and took the red function at 2, so it'd be about -1, probably -1.7-ish, okay, and then added that to the y value here on the red curve at an x value of 2, so it'd be a height of 2. If I add that number right there, that y value and that y value, it's going to come back and give me that point right there where my curve is passing through. Is that okay with everybody? Okay. Just give you maybe another way of viewing that. Let's say so I'm going to ask this thing to highlight a point that is going to have the x value that is at A, but then the y value for this point that's going to be highlighted, I want it to be the y value at B plus the y value at C. And that, so the y value at B would be f of, in this case, like 1.3. Does that make sense? Or 1.48, okay? And the y value at C is going to be -1.78. So when I hit enter, it should take the y value at that point and the y value at that point and add them together. Does that make sense, everybody? Okay. So I hit enter, and it gives me point D there. And I'm going to make that purple. Let's make it an X and make it a little bit bigger. So that point right there is the sum of f and g, f of x and g of x at, in this case, 1.48. Okay? So as I move this point A around, or move this line around here, okay, you see how that point D moves, right? And that point D is the sum then of the red line y value and the green curve's y value at those values of x that A is passing through. Okay? Well, if I trace that point, okay, it highlights all those ordered pairs. Okay? And if we actually type in f plus g of x, got caps on, x, no. What in the world? Every time I hit my, it's like X's. My keyboard's messed up. Every time I hit every time I hit X, my caps lock turns on. F plus G. Unreal. Give me a second. Let me fix this. Okay. Oh, that's what I was. Okay. That's my fault. All right. So what was happening there? What I was typing in. So I was typing in F plus G and then putting in parentheses X. It doesn't need that because of the way I've defined this. So basically, if I do this, what it's doing, and that curve is not F plus G of X. That curve is F plus G times the line defined at X. Does that make sense? So that's F plus G times X. That's not what I want. So it's this, okay? If I look at that, does that curve there match up to what was being plotted by the sum of that Y value on the green curve and the Y value on the red curve? Is that okay with everybody? Does that image make sense? Now, come over here. If I look over here, why does it stop graphing that point? Okay, because the square, so there's nothing to add together, right? It's got the Y value off the red, but it doesn't have a Y value off that curve anymore to add together. So it doesn't have an output, okay? So that's something we're in. So that's why the domain, when I look at this, my domain for this overall function right there is going to be the domain of how these two overlap, okay, how they intersect. So that's what the next portion of our notes here discuss, okay? When we take the two functions, could be three functions, four functions, it doesn't matter how many we have, and we add them, subtract them, multiply them, or divide them, the domain of the resultant function, the overall function, is the intersection of all of the individual functions, all the individual smaller ones that were combined, okay? And that's what we're seeing here. They're saying if F has a domain of A, okay, so A is a set of a bunch of X values, okay, that work for F, that give me an output for F, and B is the domain for G, so B is a set of X values that give me an output for the function G, okay? Then when I add F and G together, when I subtract F and G, multiply them or divide them, the domain for all of those is the intersection of A and B, or the overlap. And basically what that means is that this is identifying the X values that will produce real outputs that you can conduct operations on. Meaning I get like a number like 1/3 plus 0 or 1/3 plus 12 or something like that, where I don't get 1/3 plus undefined, because that's not an operation that I can do. That's undefined is not a real number. Okay. So what we like to do is we like to obviously give some individual functions, F and G, and then ask you to come up with what these look like, what these sums, differences, quotients, and products look like, and then analyze the domains of those things. Okay, so do an example here. So we're going to let f of x equal 1 over x minus 2 and g of x be equal to the square root of x. And ask us to find the following functions and their domains. Okay. So I'm just going to come to the side here, give myself some room. We had f of x equals 1 over x minus 2, and we have g of x equaling radical x. Okay? Several ways of doing these domains and structuring them so that it makes sense to you. What I like to do is I like to just figure out, what is the domain of f of x, which, if we go back to our notes, that was calling that set A. Okay? So what is my domain here for f of x? Close. I agree. I don't agree with the square bracket, but I do agree with this part. 2 to infinity. Those numbers will give me. I can't put 2 in, right? I cannot put 2 in. Now here's my question: can I put -5 in? So I need to include those as well. So I need actually values from -infinity up to 2, and we'll union that to 2 to infinity. And again, if we're struggling with that, it might make sense to draw our number line and think, okay, what is the only, because it's division, so division, we basically write that little equation, x minus 2 cannot be 0, so x cannot be 2, so we put a open dot on 2, and we graph in both directions from that then, and we start to think, okay, well, what's the first x value that this kind of vertical line would come in contact with? First x value would be -infinity. We'd get up to 2, but we can't use 2, so we skip over it, and that's what this here is saying. And once we skip over it, 2 to infinity will be then that second portion. Is that okay? All right. Now, let's talk about the domain of g of x. And that's what our notes is calling the set B. Okay? So what would be the domain there? What numbers are you not allowed to take the square roots of? Negative numbers. So then the numbers that I am allowed to take the square root of would be 0 to infinity. Okay? So now I've got the individual domains of those smaller functions. They're going to ask us then, can you find what f plus g of x would look like? Okay, so they want you to write the combined function, so that's going to be f, which was 1 over x minus 2, and then we add to it, because of that addition there, we're going to add to it radical x. Okay, now I'm not worrying right now or really concerned about our ability to maybe simplify that. If you wanted to condense that into one fraction, you look up on the whiteboard up there, that actually simplifies, if I want to put it as one fraction, as 1 plus 2, or the square root of x cubed minus 2 root x all over x minus 2. I'm not concerned right now about our ability to do that with at least this function. Okay? Throughout the course of the year, you will get better at simplifying those things and generating that, but it's not necessary right now. Yes? Yeah, you can. So you got an option. You want to write it as x times radical x. That's fine. Yeah, either one's fine. So now if I look at that, they want to know what is the domain of this. Well, the domain of this, the domain is A intersect B. Okay, if we think about what B, I didn't draw a graph here for B, but that would have been from 0. We would shade that in and graph to the right. So if I want A intersect B, and this might be something that some of you can do in your head, which is great. My hope is that eventually we all can do this in our head without a graph. But if I want to go A intersect B, that's the overlap. So I'm going to put A on a graph, and I want to put B on a graph. So A would be this set of values. Nope. Circle's at 2, isn't it? Be that set of values. And then B had the closed dot at 0. And we'd be graphing that way, right? Now the intersect means it's the overlap. So where do they start overlapping? Left to right, where do they start overlapping? Start at 0, right? And then we move all the way up to right there. Are they overlapping on 2? No. Okay? So I jump over 2, and are they overlapping all of this region? Okay, so how do we write that? Good. Okay, so that then is the domain of f plus g. If we were to graph f and x individually, or sorry, f and g individually, which would look like, so f of x is 1 over x minus 2. Okay, so that curve there. And we see that the issue that we get is here at x equaling 2, right? Okay, we have an asymptote there. Okay, when you get to calculus, you'll talk about limits and understand why this thing's not defined here at 2 is because the definition of something being defined means that, like right there where my cursor is, okay, I know that's defined at a y value of 1 because as I move my x's from the right-hand side of 3, okay, kind of put my finger over here. So as my finger is over here on the graph and I'm moving this way in x's, or in regards to my x's, my y value is approaching a height of 1, right? If I'm moving from this way, from the left with these x's, okay, so marking my y values on those x's, is my y value, as x is getting closer and closer to 3, is my y value getting to 1? So the idea is as I move from the left-hand side and the right-hand side along the x-axis and trace any y values, do my fingers end up meeting? Okay, so that means by definition we have a limit existing here, and that means that is defined. Well, if I look at this value of 2, okay, hand on the left-hand side here on this left-hand branch, where's your finger going down there? But what's the y value? Going down to negative infinity, right? What's my y value here going to? Infinity. Do my fingers meet? No. So that means that at 2, there is not a defined value for this function. And that's the idea of asymptotes. So that's the reason why, division by 2, or sorry, x being 2 gives me division by 0 is a problem here. If I then look at the square root of x, which is that one, okay, again, not defined over here, right? Okay, only defined at 0. And now the question is, well, what does f plus g look like? Should look like that orange curve. And that's exactly what we wrote by hand, right? And you see that the domain, does it still start at 0? Okay, I can ask what h of 0 is, and it will give me an output. H of 0 is negative 1/2. Okay? Do you still see an asymptote here at 2? Meaning that if I type in what is h of 2, it tells me infinity in this case, which is essentially a number that's undefined, right? Okay? But everywhere else, it's defined for. Every other, if I say h of 4, it'll give me that value right there. If I say h of 6, it'll give me that value right there, right? Okay? If I say h of 1, it'll give me 0. So that domain that we found by hand is then modeled accurately by the graph. Okay? Now, the next thing you're going to do is say, okay, well, what is f minus g? F minus g of x is simply 1 over x minus 2 minus root x, right? Just take my two functions, slap them on the paper, and put a minus sign between them. And now to ask for the domain. Well, the nice thing is that we've already found the domain for f plus g, so the domain for f minus g is identical. Does that make sense? Because the individual parts still have to have outputs that we can subtract, just like we had to have outputs like to add. Does that make sense?
Does this have to be a specific number, or can I?
Yes, because you want to take, remember taking your range, so your smallest number and largest number, and dividing those by how many classes we had. Does that make sense? Okay. So we got domains. A intersect B again. That's the domain then of the difference. So we go 0 to 2, union 2 to infinity. So once you find the domain for the sum, you've got the domain for the difference, you've got the domain for the quotient, okay, and you got the domain for the product. The only thing that's an issue is when we get to the quotient, we'll have to address one thing. If I want to go f times g, well, that's 1 over x minus 2 times radical x, okay? Now on ones like this, because the algebra is not all that involved in simplifying this, because those are two fractions, right? I will ask you to simplify that, or I think it's something we should be able to do. But the domain, again, is still A intersect B, okay? So 0 to 2, union 2 to infinity, okay? And you can see, if we go back to this, okay, so that was the sum. If we do the difference, f minus g, it gives me that. Okay, if I go, we didn't do this one on paper, but if I go g minus f, it gives me that. And you see there should be a relationship between those two. You see that one there and that one there? Are there reflections across the line y, or sorry, the line y equals 0, the x-axis? Okay, and that's because if I take 5 minus 3, you get 2, right? But if you take 3 minus 5, you get negative 2, you get its opposite, okay? Which is essentially the reflection across the x-axis. If I do f times g, we get that red curve, okay? Is that the same thing if I do g times f? Yeah, so the commutative property exists there. Now if we do g divided by f, we get that curve. If I get f divided by g, I get that curve. So those are completely different, right? Okay. So let's kind of talk about the domains of those. This one, this blue one, looks like we've got a domain problem here at 2, right? When I look at this red one here, it doesn't look like we maybe have an issue with the domain. So unless I go, let's see, if I evaluate this, so it's t is the function. I go t is 0, see what it spits back. Gave back 0. We'll talk about that here in a minute. Okay. So let's do f divided by g. See what that looks like. F divided by g of x should look like, so f was 1 over x minus 2, right? And g was radical x. The domain of this, so it's division, the domain is still A intersect B. However, we have the added feature that your bottom function, in this case, which is g of x, cannot be 0. Okay, so A intersect B was still 0 to 2, union 2 to infinity. Okay? What would make the bottom, though, so g of x is my function on the bottom, which is that right there, right? What would make that quantity, radical x, what value of x would make that 0? 0. See how that's a problem right here then? So the only thing I have to do then to adjust the domain here for the division is change that bracket to a parenthesis. Okay? And we should see then, when we do, what was it, f divided by g? We do f divided by g which is this one here. If I ask it to find f sub 1 of 0, see how it gives me negative infinity, which is essentially undefined, right? Okay. Let's go then to G divided by F. Same approach. We have 1 over, not 1 over, it's radical x, right? G was radical x. And now my denominator is 1 over x minus 2. Okay, so it's still the same domain. It's still A intersect B, but now f of x cannot be 0. Okay, A intersect B, so that's going back to A intersect B was 0 to 2, union 2 to infinity, right? Okay. Is there a situation where that denominator can be 0? Huh? Well, careful. I see what you're saying, but that's not answering the question of where it can be 0. Can 1 over x minus 2 ever be 0? No. Okay. You know, you cross multiply or whatever, you get 1 equals 0. That's false. Okay, it can't happen. No matter what, think about no matter what number you plug in there for x, you can never make 1 divided by something be 0, right? Now we can get, you know, if I take 1 divided by 2, 1 divided by 3, 1 divided by 4, my quantity, my quotient keeps getting smaller and smaller, okay? But I will still always have a remnant of something. Does that make sense? If I take 1 divided by, you know, 1 million, I still have an amount left over. It's very small, getting close to 0, but it's still something left over. So I can't make this get to 0. But what Jimin was saying is that I can, at some point, have 1 divided by 0, right? And at what position is that? Yeah, at 2. And is that already taken care of in our domain here? So do I need to kick anything else extra out? No. Okay? So that's a situation where sometimes your domain of a quotient will be the domain that was the same as the sum or the difference or the product simply because of how it worked out there. Okay? In your homework, you're going to see a question like that. And hopefully from what I've shown you with GeoGebra, that this would not be something that would kind of blow your minds. But they're going to ask you to take these two functions. We don't have rules for them. But they're going to ask you, what is f plus g of, like, 8? So I came out to the x value of 8 out here, and I go to f, which is the red curve, and I find out what is that y value. So the y value of f at 8 is 3, right? And then I do the same thing for g, which is going to be at 4, correct? What do I do with those two values to find f plus g at 8? I'm together, right? Okay, do that. Do whatever algebra is there. If they say add them, multiply them, divide them, whatever. Okay, does that make sense? Okay. Tomorrow we'll start off with a couple more examples of that, but then we'll get into dealing with composite functions. Like I said earlier, my number one concern is us being able to identify what the domains are of these things, not so much the skill of simplifying and that sort of thing. Okay, I want to know what the domains are. Domains become very important for us to work in calculus. Okay, so that's a skill and knowledge that's very, very important to us. No new homework.